Welcome back to the deep dive. Today, today we are doing an intervention.
An intervention. That sounds a little serious.
It is serious because if you are listening to this and you work in tech or you follow AI even casually, your timeline is currently on fire. It is absolute chaos out there.
Let me guess. 3 letters. MCP.
MCP, the Model Context Protocol.
Mm.
I opened YouTube this morning. Big mistake, by the way. And it was just wall-to-wall thumbnails. You know the ones with the glowing eyes and the shock faces?
Oh, yeah, the typical algorithm bait.
Exactly. Titles like MCP changes everything or the end of apps and why you need MCP now. It's the hype cycle on absolute steroids.
It's the classic new shiny object syndrome. I always see this every 6 months in this industry.
Yeah, I do. But here's the problem, and this is exactly why we're doing an intervention today. I actually sat down and watched 3 of those videos. And then I went and opened the documentation.
Ah, you did the forbidden thing. You read the manual.
I read the manual, the official spec from Anthropic. And let me tell you, there is a massive, massive gap between what the influencers are shouting about and what the engineers are actually building.
That's usually the case, though, right? I mean, the influencers are selling the dream of the technology. The documentation explains the actual plumbing.
The plumbing.
Yes.
And the plumbing is what matters, because if you don't understand the plumbing, you're going to get wet. Or, well, in this case, you're going to build something that completely breaks in 3 months. So that is our mission today. We are completely ignoring the hype.
Sounds good to me.
We are ignoring the end of apps hyperbole. We're going to do what we always do in this deep dive. We're going to respect the source material.
We read the doc so you don't have to.
Exactly. We read the specs. We looked at the architecture diagrams on GitHub.
Right.
We even dug into the trust and safety warnings that nobody seems to want to talk about.
Which are fascinating, by the way, and frankly a little terrifying if you don't know what you're actually looking for.
They really are. So buckle up. We are going to break down the Model Context Protocol. We're going to explain why it's being called the USB-C of AI. We're going to do the actual math, literally the algebra, on why this solves a scaling problem. And we are going to have a very honest, very spicy conversation about security and corporate strategy.
I like the sound of that.
But first, for the person who has been living under a rock, or maybe just has a healthy relationship with the internet and hasn't seen the acronym yet, let's just start at 0. What specifically is the Model Context Protocol?
Right. So if you strip away all the marketing fluff, MCP is an open standard. It is a standardized way to connect an AI assistant, so like Claude or potentially ChatGPT or any open source model, to the systems where your data actually lives.
Okay, systems where data lives. Give me the tangible real-world example.
I'm talking about your Google Drive, your Slack workspace, the Git repository where your code lives, even the local Postgres database running right there on your laptop.
So simply put, it connects the brain, the AI, to the filing cabinet. Your stuff.
That's it. It is the connective tissue. It's the bridge.
Okay, but here's where I have to play devil's advocate for a second.
Yeah.
Because connecting AI to data, haven't we been doing that for 2 years? I mean, we have RG.
Retrieval augmented generation, yeah.
Right. We have plugins. We have custom API wrappers. Why is this specific protocol a big deal? What is the actual problem it's solving that those things didn't already solve?
The problem isn't that we can't connect AI to data. The problem is that we're doing it stupidly.
Oh,
Inefficiently. Very inefficiently. If you look at the source material, they describe the current state of frontier models, even the really smart ones like Claude 3.5 Sonnet or GPT-4, as being trapped behind information silos.
Trapped. I like that imagery, actually. It implies they're prisoners.
In a way, they kind of are. Think about your typical daily workflow right now. You're working on a big project. You have a PDF spec sheet sitting in Google Drive. You have a conversation about it happening in Slack. You have the actual code base in GitHub. And then you have the AI open in a browser window over to the side. What are you doing?
I'm copying and pasting. I'm alt-tabbing constantly. I'm downloading the PDF and re-uploading it to the chatbot. It's a mess. It's the copy-paste industrial complex.
Exactly. You are the bridge. You, the human user, are the manual data pipeline. And that's fine for a hobbyist. But if you're trying to build an actual system, it's a nightmare. Because right now, without a standard, every time you want an AI to talk to a tool, you have to build a custom bridge.
Right. So if I want to connect Llama 3 to my calendar, I have to write a custom Python script specifically for that API.
And if you decide to switch to Claude tomorrow,
I have to rewrite the script.
and if your company switches your calendar from Google to Outlook,
I have to rewrite the script again. It's endless.
And that brings us to the analogy that Anthropic uses right there in their introductory blog post. And I know tech analogies can be a little cheesy sometimes, but this one is actually perfect. They call MCP the USB-C port for AI applications.
I saw that in the docs, and I love it because I am definitely old enough to remember the drawer of doom.
The drawer full of cables.
Yes. You know this drawer. Listener, I know you know this drawer. The one in your kitchen or your home office that is just a tangled nest of black plastic. You had a mini USB for the digital camera, a micro USB for the Kindle, a 30-pin connector for the old iPod, a proprietary brick for the laptop.
And if you lost the specific cable for that specific device, the device was just a brick. It was completely useless.
It's a disaster. You couldn't just plug in anywhere. You had to hunt for the right dongle or the right adapter for 20 minutes.
That is exactly where AI infrastructure is right now.
Lovely.
We are deep in the pre-USB era. Every model has a proprietary way of asking for data. Every tool has a proprietary API. It's just a massive mess of custom adapters.
So the pitch for MCP is basically, hey, everyone, can we please just agree on the shape of the plug?
Precisely. Let's standardize the socket. If every tool, whether that's Slack or Google Drive or Linear, builds a USB-C port, which in this case is the MCP server, then any AI model can just plug right in. One standard. Any model. Any tool.
That sounds great conceptually. Let's all hold hands and get along. But in the documentation, they actually break this down mathematically. And I really want to walk through this because I think this is where the business value actually clicks for people. They call it the N times M problem.
Yes. This is the core efficiency argument. This is why a CTO or a VP of engineering should actually care about this. This isn't just about making things slightly easier for a developer. It's about making them scalable at an enterprise level.
So walk us through the algebra here. Let's imagine a world without MCP, the world we live in today.
Okay. Let's say you are running a software shop. You're building an internal AI platform for your employees. You have, let's say, M number of tools. M equals 10. You have Jira, GitHub, Slack, Postgres, Notion, stack, 10 tools.
Got it. M equals 10.
And you want to test out different AI models because the landscape is always changing. You have N number of models. You want to try Claude. You want to try GPT-4 Gemini, maybe a local llama model for privacy. Let's say N equals 5.
5 models. 10 tools.
In the old world, every single model needs a unique integration for every single tool, because GPT-4's function calling API is fundamentally different from Claude's tool use API. They speak completely different dialects.
So I have to write code to connect Model A to Tool 1, then I have to write more code to connect Model A to Tool 2, then Model B to Tool 1.
You are multiplying. It's N times M, 5 times 10. You have to build, test, secure, and maintain 50 separate custom integrations.
50. And maintain is the absolute key word there, because APIs change all the time.
Exactly. Slack updates their API endpoints. You might have to go in and fix 5 different bridges, because each of your 5 models handles that API response slightly differently. It's an exponential maintenance nightmare. It basically guarantees that you will stick to one model because the switching cost is just too agonizingly high.
You get locked in not because the model's necessarily better, but because you're just too tired to rewrite the plumbing.
Bingo. That's technical debt accumulating before you've even written a single line of actual product code. Now let's flip it. Let's introduce MCP to the equation.
The universal USB-C port.
Right. Now you completely change the architecture. You build one MCP server for each tool. So for your 10 tools, you build 10 servers. That's it.
Okay, 10 servers.
And for your AI applications, the model, you build one MCP client for each one. So for your 5 models, you enable the client 5 times.
So the math becomes addition instead of multiplication.
Exactly. It becomes N plus M, 5 clients plus 10 servers. That's 15 total pieces of infrastructure to maintain.
We went from 50 custom headaches to 15 standard components.
And here is the real kicker. If you add a new tool down the line, let's say your company gets fed up with Jira and starts using Linear instead, you just build one MCP server for Linear. And instantly, automatically, all 5 of your models can talk to it.
You don't have to go back and touch the models at all.
Not a single line of code on the model side. You just plug the new tool into the standard socket.
That's the aha moment. It transforms the problem from a multiplication problem, which scales terribly for any engineering team, to an addition problem, which is totally manageable.
It creates a true ecosystem. Just like USB-C allowed 1,000 different random peripheral companies to exist because they didn't have to worry about how to build a proprietary connection to a Dell laptop or a MacBook. They just followed the spec and focused on their product.
Okay, so we have the math, we have the analogy. But this is the deep dive, and we promised not to just skim the surface with marketing speak. I really want to know how this thing is actually wired. Because plug is a metaphor. There isn't a physical cable connecting my local database to the cloud.
No, unfortunately not, though plugging a physical AI cable into a hard drive would be kind of retro and cool.
It really would.
Yeah.
But when I looked at the architecture diagram in the GitHub repo, it lays out 3 very specific roles. And I think there is some genuine confusion about these out there, especially the difference between the host and the client.
Yeah, the naming convention they chose is a little tricky, especially if you come from traditional web development. It's easy to get your mental model flipped around.
So let's break them down clearly. Role number 1, the host.
The host is the application that you, the human, are actually looking at. It is the user interface.
Give me a real-world example of a host.
The Claude Desktop app on your Mac, or a code editor like Cursor or Zed, or potentially a custom terminal interface you built. It is the container where the conversation actually happens. It's the thing you click on and type into.
Okay, so if I'm sitting at my desk right now, the host is just the window on my screen.
Correct. Now, role number 2, the client.
See, this is the confusing one.
It is, because normally in web dev, we think of the client as the user or the browser. But in MCP, the client is a specific piece of code that lives inside the host application. It is the protocol connector.
So it's totally invisible to me as a user.
Yeah, totally invisible. Think of the host as a house. The client is the plumbing system hidden inside the walls. You don't see the pipes, but the pipes are what make the water flow when you turn the faucet. The client's entire job is to maintain the connection with the external world. It handles the handshake, it negotiates capabilities between the model and the tool, and it manages the actual message traffic back and forth.
Got it. Host is the house. Client is the pipes in the walls. And that leads naturally to role number 3, the server.
The server is the water main out in the street, or the well. The server is the piece of software that sits directly on top of your data source.
So if I want to talk to Google Drive, I need a Google Drive MCP server.
Exactly. And this server is usually a very lightweight program. It doesn't contain the Google Drive data itself. It just knows how to talk to the data. It translates the standardized MCP requests into the specific proprietary API calls that Google Drive requires.
So it's essentially a universal translator.
It's a translator and a gatekeeper. It's the thing that receives a standardized message and says, okay, the AI wants to list the files in this specific folder. I know how to securely ask Google Drive for that list, so I'll go get it, and then I'll translate the answer back into the standard MCP format to send down the pipe.
Now, technical question here that I saw debated in a forum.
Yeah.
How are they actually connecting? Is this over the open internet? Is it Bluetooth?
This is a really key detail of the architecture. Right now in the primary implementation, the connection is strictly local. It uses something called standard input-output, standard I/O.
Standard I/O. That sounds incredibly old school.
It is very old school. It's basically one program piping text directly into another program running on the exact same computer. It's how Unix tools have talked to each other for like 50 years.
Why do that, though? Why not use HTTP or a fancy WebSocket like everything else today?
Simplicity and, more importantly, security. By keeping it over standard I/O, the data never actually leaves your machine unless the server specifically calls an external cloud API. So that Google Drive server is actually running as a little background process right on your local computer, talking directly to the Claude Desktop app via a local pipe. It's incredibly fast, and it's inherently sandboxed from the outside network.
Okay, that makes perfect sense. So we have the host, which is the app, talking to the client, which is the connector, which pipes data locally to the server, which acts as the translator to hit the actual data. That's the full chain.
That is the chain. And what's really elegant about it is that the client, the host app, doesn't need to know anything at all about how Google Drive works. It just sends a generic list resources command. The server does all the heavy lifting of figuring out the API.
So the pipe is built, we understand the pipe, but what actually flows through it, the documentation lists 3 specific primitives or capabilities.
Yeah.
And I think these are vital to understand because they basically define the limits of what the AI can actually do in your system.
Yes. If you are a developer building a server, you have to make a conscious decision. What am I allowing the AI to do here? You have 3 distinct choices.
Choice number 1, resources.
Resources are strictly read-only data. Think of this as giving the AI a library card. It can look at the books, it can read the pages, it can quote the text, but it cannot write in the margins, and it certainly cannot burn the library down.
So what are some everyday examples of a resource?
A local log file on your machine, a specific row of customer data in a database, the current real-time price of Bitcoin from an API. The text content of a document on your desktop, it is purely context. It's a one-way information flow from the source straight to the model.
Safe, simple, very low risk.
Generally, yes, it's entirely passive. The AI is just an observer gathering facts before it speaks to you.
Choice number 2, prompts.
This is a cool one that I think people overlook. Prompts in the MCP context are reusable templates. Think of them as saved corporate recipes.
Explain that a bit more. Why do I need a whole server architecture to save a prompt? I can just copy and paste it or type it out.
You can, but let's say you are a lead developer at a big company and you have a very specific, standardized way you want your team to use AI to generate unit tests. You want the AI to use a specific testing library, you want it to follow a strict naming convention, and you want it to handle errors in a very specific company-approved way. That prompt might be 50 or 100 lines long.
And I definitely don't want to type that out or hunt for it in a wiki every single time I need a test.
Right. So you code that massive prompt directly into the MCP server as a prompt capability. Then inside the host app, the user just clicks a button or types /test, and the server dynamically feeds that perfect standardized prompt right into the context window. It ensures total consistency across your entire engineering team.
It's basically like a macro. Or a shared intelligence snippet.
Exactly. It standardizes the how. It completely removes the blank page problem for the end user. Instead of every developer having to figure out the optimum way to ask the AI to do a task, the server provides the absolute best practice way to ask.
Okay, so resources are for reading, prompts are for templates. Now we get to the big one, choice number 3, tools.
This is the danger zone, and honestly the fun zone.
Tools.
Tools allow the AI to actually take action. This is the exact moment where a passive chatbot becomes an active agent. Resources are for reading, tools are for writing.
Give me some concrete examples of what a tool can actually do on my machine.
A tool can write a new file to your hard drive. It can execute a SQL query that updates a live customer record in your database. It can send an automated message in your company Slack. It can create and merge a pull request in GitHub.
So it essentially has hands.
It has hands. It can touch things. And this is where the architecture gets incredibly powerful because the model doesn't just know things anymore. It can do things on your behalf. It can look at a prompt and say, oh, you want me to schedule a follow-up meeting? I see you have a calendar tool available on the server. I'm going to construct the data payload and use that tool right now.
It effectively just calls a function on your computer.
Yes. And this brings us right back to that N times M efficiency problem. The model itself doesn't need to know how to authenticate or parse Google Calendar's messy API. It just needs to know that there is a tool exposed called create event, and that tool requires 2 basic arguments, a time and a title. The local MCP server handles all the messy API translation.
That is fascinating. But listening to that, it also sounds incredibly risky.
We will get to the risk. Trust me, we are going to spend some serious time on the risk.
Good. Because now that we truly understand what MCP actually is, a protocol, a standard, a pipe, we can finally look at all those YouTube narratives out there and see which ones actually hold water. And honestly, based on the docs, a lot of them just don't.
Let's debunk them. I'm ready.
Myth number 1. MCP is an app store for AI. I hear this constantly. People are saying Anthropic is building the ultimate app store. They are going to be the Apple of the AI generation.
Yeah, that is false. It is demonstrably entirely false.
Why are people saying it then? What's the difference?
Think about what an app store fundamentally is. It is a marketplace. It is highly centralized. You go to Apple's server, you find an app, you download it, Apple reviews the code to make sure it's safe, and Apple takes a 30% cut of the money. It is a classic walled garden.
Right. You play entirely by Apple's rules or you don't play at all.
MCP, on the other hand, is a protocol. It is an open standard. It is much more like HTTP for the web or SMTP for email. When you send an email to your coworker, do you go to the email app store to buy permission to send that specific message?
No, I just send it. Because my email server speaks the exact same open language as their email server.
Exactly. MCP is entirely peer-to-peer. There is no central server sitting at Anthropic headquarters in San Francisco that approves your MCP connection. If you write a custom server for your weird private home automation system and you connect it to your local client, Anthropic doesn't know about it. In fact, they technically can't know about it.
So it's not a store. It's a language.
It's plumbing. Nobody owns the plumbing inside your private house. You do. There is no buy button. There is no revenue share model built into the protocol.
That is a critical distinction for people to understand.
Yeah.
Because investors are out there looking for a massive platform play, But this is actually a standardization play.
Exactly. It's about laying down base infrastructure, not setting up a retail storefront.
Okay, myth number 2, and this is the one that really scares me a little bit. MCP makes AI safe for the enterprise. People hear words like protocol and standard and foundation, and they immediately assume security.
This is the dangerous one.
All right.
If you are listening to this and you take absolutely nothing else away from this deep dive, please listen to this. MCP does not make AI inherently safe.
That's a bold statement.
It's literally in their docs. If you go and read the trust and safety section of the official specification, it is brutally honest about this. It says essentially the protocol cannot and does not enforce safety principles.
Break that down for us. Why can't a protocol enforce safety?
Because again, it's just a pipe. If I build a physical pipe from my house to your house, the pipe itself doesn't know if I'm pumping clean drinking water or gasoline or toxic waste. The pipe's only job is to carry the payload from point A to point B.
So if I connect an MCP server to my company's critical payroll database,
And you explicitly give the AI tools capability, meaning write access,
and then the AI hallucinates or gets confused about a prompt,
the AI can absolutely delete the entire payroll database. And the MCP protocol will happily and efficiently deliver that delete command because perfectly formatted standard I/O messages are what it's built to deliver.
the pipe works perfectly while the building burns to the ground.
Exactly. The security model puts 100% of the responsibility on you, the developer, and you, the enterprise user. You have to build the strict guardrails inside the server logic yourself. You have to implement human-in-the-loop approval checks before a tool runs. The protocol has no magic safety net. It won't save you.
So when these tech influencers say it's enterprise ready, they really just mean the connectivity is ready. They definitely don't mean the governance or the compliance is ready.
Correct. We have the plumbing installed, but we don't have the pressure valves, the locks, or the security cameras set up yet.
That's a huge distinction. I feel like that myth alone is going to cause some major headaches for IT departments in about 6 months.
Oh, absolutely. There will be incidents. Someone is going to connect a read-write server to something incredibly important, trust the model way too much, and we are going to have a massive tech news headline. It's inevitable.
Okay, that leads perfectly into myth number 3. The underlying motive. Anthropic did this just to be nice. You know, the narrative of, look at the good guys open sourcing everything for the dev community.
Look, I'm sure the engineers working at Anthropic are genuinely lovely people who want to help developers, but corporations don't spend millions of dollars and thousands of hours developing an open protocol purely for charity.
So what is the actual business play here? Why give this away for free? Why hand it over to open source foundations?
Because they want to commoditize the compliment.
Ooh, a classic MBA term. Explain that for the listeners.
It's a brilliant, classic business strategy. If you sell cars, your product is the car. You want gas, the complement to your product, to be as cheap, standard, and available everywhere as humanly possible. If you sell hardware printers, you want paper to be standard sizes and dirt cheap.
In this scenario, Anthropic sells the model, the brain.
Right. The smart reasoning brain is their core product. That's what you pay API tokens for. But what does the brain desperately need to actually be useful in the real world?
It needs data. It needs context.
Exactly. Right now, getting context into a model is hard and expensive. It requires all those custom bridges we talked about earlier. If Anthropic can make getting context cheap, easy, and standardized,
Then the brain becomes infinitely more valuable.
Exactly. If every SaaS tool out there, Salesforce, Jira, Zendesk, SAP, builds an MCP endpoint out of the box, suddenly Claude becomes a super employee without Anthropic having to write or maintain a single line of custom integration code themselves.
They're completely outsourcing the tedious integration work to the rest of the software industry.
They are strategically creating a world where their main product, the Frontier Smart Model, has the biggest possible advantage because it innately speaks the universal language of business data. It's the ultimate network effect. They want to own the standard language so they can comfortably sit right at the center of the web.
It's incredibly smart. It's not evil at all, but it's definitely a calculated corporate strategy.
It's brilliant. If they tried to keep this proprietary, they would just be fighting a grinding, endless war on integrations with every single software vendor. By opening up entirely, they invite everyone else to build the paved roads that lead directly to their castle.
So let's talk about what happens if this strategy actually works. If MCP actually becomes the true USB-C of AI, what happens next? What breaks in the current tech ecosystem? We've talked a bit about the battle for the pipe.
What breaks immediately is the wrapper business model.
The wrappers. You mean those Thousands of startups that are basically just a ChatGPT prompt, but with a custom connection to, say, Notion or Airtable.
Exactly those. There are thousands of seed-funded startups right now whose entire value proposition is simply we built the hard bridge between an AI and this specific tool.
And if MCP makes that bridge a standard free built-in commodity,
Then those startups lose their entire protective moat overnight. Think about it. If Notion ships an official native MCP server, why on earth would I pay a third-party startup $10 a month just to connect Notion to Claude? I'll just plug it in directly myself for free.
so the real value completely shifts. It moves away from the middleware connector companies and rushes back to the source data and the core models.
Correct. The strategic moat moves. For the last 2 years, the entire AI competition was simply who has the smartest model. Is GPT-4 smarter than Claude 3? Is Gemini catching up?
It was an IQ versus IQ battle.
But if protocols like MCP standardize the data access, the moat becomes about distribution and defaults. It stops being about who is 5% smarter on a benchmark and starts being about who organically controls the pipe and the user interface.
Let me see if I have this right. If I'm a developer working inside the Cursor IDE all day, and Cursor has MCP built right in, I'm just going to use whatever model integrates most seamlessly with that pipe. I might not care if a slightly smarter model exists elsewhere if it doesn't plug into my tools.
Exactly. Friction dictates usage. And we are seeing this play out right now. Look at the early adopters they explicitly mention in the source notes. Block, which used to be Square, Apollo, Replit, CodeEMZ.
Notice a trend there. Those are almost all hardcore developer tools.
Right. Because developers uniquely feel the pain of context switching the most. They live it every day. The CTO of Block actually had a fascinating quote in the press release. He said, "Open technologies like MCP are the bridges that connect AI to real-world applications." When a massive financial infrastructure company like Block says that publicly they aren't just playing around with a weekend toy, they're looking closely at core enterprise infrastructure.
It's the infrastructure play. It's fundamentally boring plumbing, but it's always where the real lasting money is made.
It's always where the money is.
Yeah.
The gold rush always enriches the people selling the picks and shovels.
Okay, we've been very high level for a while now. We've done business strategy, network effects, N times M algebra. I want to bring this right back down to earth for the person listening right now.
Yeah.
Because one of the genuinely coolest things about this particular topic is that it's not just white paper theoretical. You can literally see it running on your personal computer right now today.
That's very true. It's hiding right there in plain sight.
Let's do the try this yourself exercise that we put together from our show notes.
Yeah.
Listener, if you are near a computer, and specifically if you happen to use the Claude Desktop app on Mac or Windows DAC, I want you to do this with us.
Step 1, open the app.
Step 2, click on the settings menu. It's usually hidden under your initials in the bottom corner.
Step 3, look for a specific tab in the menu called Developer, or sometimes just MCP, depending on your version.
And what do you see when you open that?
You'll likely see a list of active connections. And you might see something explicitly called File System or Computer.
That thing you're looking at, that exact item, that is an active MCP server.
It's running locally right on your machine. When you drag a heavy PDF into the Claude interface and ask it to summarize Chapter 3, it is silently using the MCP protocol in the background to read that file from your hard drive.
You are already using the future. It's not sci-fi magic. It's the very real, boring plumbing that makes the magic happen seamlessly.
And for the tinkerers out there, the listeners who know a little bit of Python or JavaScript or TypeScript, you can literally build a custom one of these yourself in about 15 minutes.
Oh, yes, the weather server example from the
Yeah.
Quick Start Guide.
Yes, the ultimate hello world of the MCP ecosystem. You can write a tiny little Python script that hits a public free weather API like OpenWeatherMap. You define a single tool in the code called getWeather. You point your Claude Desktop apps config file to run that exact script.
And then what happens?
And then you open up Claude and you just casually ask, do I need an umbrella today?
And instead of doing the usual AI apology where it says I am an AI model and I do not have real-time access to the weather, it actually pauses.
It pauses. The client inside Claude talks to your local server over standard I/O. Your server hits the weather API. The API sends the current data back to your server translates it, and Claude suddenly says, yes, actually it's raining in Seattle right now, grab an umbrella.
That moment, that specific feedback loop, that is the exact moment it fully clicks in your brain.
It completely changes your relationship with the AI. It stops being a smart textbook or a text generator. It suddenly becomes an active machine that can reach out and use your custom tools. It feels Frankly, shockingly powerful.
And maybe slightly dangerous.
And dangerous. Because once you successfully teach it to check the local weather, you realize, wait a minute, I could easily teach it to check my live bank balance. I could teach it to execute stock trades based on news. I could teach it to automatically deploy production code to my servers.
And that realization loops us right back around to the massive safety problem we discussed.
Which ultimately brings us to the verdict.
Right. We have to land the plane here. We've covered the core tech, the persistent myths, the corporate strategy. Now we need to give our final recommendation based on the docs. The operator verdict.
The verdict is completely split on this one. It depends entirely on who you are and what you are building.
Okay, let's start with Group A, the tinkerers, the solo developers, the indie hackers, the people just building cool productivity tools for themselves.
For you, green light. Absolute full send.
Why so enthusiastic for them?
Because the barrier to entry is basically zero. The documentation on modelcontextprotocol.io is surprisingly excellent and clear. You can run it in Docker, you can use visual tools like N8N if you prefer low-code workflows. You can easily hack together a deeply personalized assistant that actually manages your digital life in a single weekend. It is the most fun you can possibly have coding in AI right now.
It almost feels like the wild early days of the iOS App Store.
Even better, it feels like the early days of the open web. It's messy, it's totally open, permissionless, and you can build absolutely whatever you want without asking a giant corporation for an API key to their specific integration.
Okay, I love that. Now let's pivot to Group B, the enterprise. The CIO, the IT manager, the person whose job is literally responsible for securing 5,000 employees' sensitive corporate data.
For you, yellow light, maybe even a flashing red light.
Whoa. A hard stop for enterprise.
Proceed with extreme caution. Watch it closely, test it in isolated sandbox environments, but do not deploy this architecture to mission-critical production yet.
Because of that governance and safety gap we talked about.
Exactly. Think about what a CISO actually needs to sign off on a new protocol. They critically need an immutable audit trail. They need to know exactly who accessed the specific sensitive file at what time and why. MCP fundamentally does not standardize that logging yet. They also need granular role-based permissions. Marketing can see the specific folder, but engineering can only see that folder. Right now, you, the developer, have to custom hard code all of that complex access logic yourself in every single server. There is absolutely no native identity management or authentication layer baked into the protocol itself.
And what about a failsafe, the kill switch?
That's the most terrifying missing piece. If a highly capable AI agent starts going rogue, say it gets stuck in an infinite loop and starts rapidly deleting files or sending 1,000 spam emails an hour, you desperately need a centralized kill switch to instantly sever the connection. That essential security infrastructure just does not exist out of the box right now.
Yeah. So if you naively deploy this raw protocol to 5,000 employees tomorrow, you are potentially opening 5,000 unmonitored security holes directly into your corporate data without a reliable way to oversee or stop them.
Precisely. The basic plumbing is there, and it works beautifully. But the enterprise building code hasn't even been written yet.
So what does the actual timeline look like then? If we were in the Wild West phase right now, what comes next for this ecosystem?
The next 12 to 18 months are going to be hyper-focused on one word: governance. You are going to see a massive wave of new startups, ironically, probably the exact same startups who have to pivot away from being simple wrappers, building the enterprise security layer for MCP.
Basically MCP firewalls.
Exactly. Intelligent middleware that sits directly between the client and the server and strictly checks the badges. It will intercept the messages and ask, are you actually authorized by IT to do this? Are you seriously trying to drop a production database table right now? Blocked.
So the mature ecosystem will eventually wrap around the raw protocol.
It absolutely has to, because the core utility is just too overwhelmingly high to ignore. That N times M exponential efficiency game is too attractive for any CFO. Companies will absolutely adopt this standard. They just desperately need to buy the safety gear before they jump out of the plane.
I really like the idea that we are actively watching the core infrastructure of the next decade being poured right now. It's wet cement.
It is wet cement, and if you take the time to learn how to work with the cement right now while it's still wet, you get to define the final shape of the road.
That's the ultimate takeaway, I think. Don't just sit back and let AI happen to you. Take an hour and understand the pipe. Because if you understand the pipe, you ultimately control what flows through it.
I couldn't have summarized it better myself.
All right, that was a serious, deep one. My brain is slightly melted, but definitely in a good way.
It's a lot of acronyms and abstract concepts, but it's foundational stuff.
Listener, if you want to go even deeper, if you want to actually copy-paste that Python weather server code and try it, or if you want to read the full terrifying trust and safety warning for yourself, we have compiled absolutely everything in the show notes.
Head over to afrankly.substack.com. We have direct links to the Linux Foundation GitHub repo, the original Anthropic blog posts, and the full detailed math breakdown.
And hey, do us a quick favor. Share this specific deep dive with that one friend. You know exactly the one. The one who keeps sending you those AI is God, and apps are dead videos on X.
Be the good friend who finally brings the actual facts to the group chat.
Save them from the hype cycle. Give them the actual plumbing.
Plumbing is cool again.
Plumbing is definitely cool again. I love it. We are AI Frankly on Apple Podcasts, Spotify, and YouTube. Make sure to subscribe so you don't miss the next deep dive into the real tech.
See you all next time.
Are we having fun yet? Bye, everyone.